Hello students, last video we have discussed about parse trees, and this video will discuss about ambiguity in grammars and language. So how to derive the parse tree for this string? Let me revise it. See AABB, so you can go with this. S tends to get the AABB, you can substitute only A or AB, but what our string is AABB. So here you have to predict what is the production to be substituted. If I get only A, I can't get the B's because A is having only, right, A's are right, B's. Of course, we are having B. So we'll check it by substituting only A. S tends to A. For the A, we need what? A, B, B. Then we need two A's and two B's. Let me go with this. So first A, B, then go with A tends to A, B. I got the two B's. I need two A's. Then for this A, I can substitute like A. And A tends to A tends to A. I got A, B, B. Okay, well and good. We got it. Okay. See, for the S, what we have substituted A. Then go for the another substitution. S tends to A, B. Then for this B, we need two B's. Then we can go with this B, B. B tends to B. For this A, I need two A's. Then I can go with A. A tends to A tends to A. See, I got the same A, B, B from here. And A, B, B. See, for the same string, we got the two different parse trees. Then we can call this grammar is ambiguous grammar. So what is ambiguous grammar? A grammar which generates more than one parse tree is called ambiguous. That doesn't mean that only two. We can construct one more, like see, S tends to A, B, right? So B tends to B. We got one B. We need A, B. So A tends to A, B. A tends to A. And A tends to A tends to A. See, again I got the A, B, B. Now, these three parse trees are different. So if you could able to generate more than one parse tree for a string, then we can say that it is ambiguous. Right? If the derivations are different, we cannot say it. But if the parse trees are different, definitely we can say it. Right? So of course we have taken the same parse tree in the next slide. Let me just erase the ink. So this is how we got it. But I've taken three parse trees, right? Like this. We have some other possibilities. See here. I've taken these two, but they have given another one. Like we can generate any number of parse trees. Okay. So what does it mean by parse trees? Ambiguous grammar. If it generates more than one parse tree, more than one different parse trees, then you may get it out. Can't we define the ambiguity of a grammar with the derivations? Yes. If the leftmost derivation is not equivalent to rightmost derivation, we cannot tell it. But for the same string, if you give two different leftmost derivations, a leftmost derivation is not equivalent to another leftmost derivation, in that case, we can say that the grammar is ambiguous grammar. Right? So finally, we can say that multiple derivation trees, it is ambiguous. Multiple leftmost derivations, it is ambiguous. Multiple rightmost derivations, multiple derivations, we cannot say it. Right? Multiple parse trees like this, multiple leftmost derivation we'll discuss next, right? Or multiple rightmost derivations. So we are defining the ambiguity in three ways. Let me go with this, sir. How can you say that the derivations are different? Let me go with the id plus id star id. I'll go with the leftmost derivation. Okay. So first you can take this e tends to e plus e. So what is the production I've used here? E tends to E plus E. Okay, I'm not writing every time this production. Let me go with this. Then for this E, you can substitute leftmost, right? You can substitute directly ID because now E is having ID here. But then you can go with E. Sorry, this is also E, but won't affect on our concept now. Then I got ID plus, and I'm expecting ID star ID. This is a leftmost non-terminal. You have to replace this only in the leftmost derivation. Then you can go with id plus, we are expecting star, then you can write e star e. Okay, Then this is the leftmost non-terminal. Then you are expecting after plus before star id. Then let me go with id star e. And this is the leftmost. Then you can go with id plus id star id. Right. So this is the leftmost derivation one to get this string. For the same string, don't give the another rightmost derivation. If you could able to give one more different leftmost derivation, then it is ambiguous. Right. I'll go with the another leftmost derivation. Earlier I have substituted e plus e, right? Then I'll go with e star e. What is the need of going with that? So e star e. And what is the leftmost non-terminal here? E. Then to get this e, before star what you are expecting id plus, then I'm going with e plus e star e. This is a leftmost non-terminal. I already got plus and star. Then I need only IDs. Then ID plus ID star ID. Sorry, ID plus E because we have replaced only the leftmost non-terminal. Then the leftmost non-terminal is this ID plus ID star E. And the leftmost non-terminal is this. Then you can write ID plus ID star ID. Guys, don't replace more than one non-terminal at a time in the derivation. While you are doing, you can do it. But while you are deriving it, then don't do it. While you are writing in the exam, don't do like this. Okay. Don't substitute at a time. Two non-terminals. You have, see, same leftmost derivation in each and every step, we have replaced the leftmost non-terminal only. You can cross verify here. In each and every step, the leftmost is replaced, leftmost is replaced, leftmost is replaced. Here, the leftmost, the leftmost, the leftmost is replaced like that. So we got the, for the same string id plus id star id, okay, we got the two different leftmost derivations. Then we can say that it is also ambiguous grammar. So what is ambiguous grammar? Either it will give you the two different leftmost derivations or two different rightmost derivations or two different parse trees. If anything is possible, we can say that it is ambiguous. Okay. So what is ambiguity, guys? If the grammar is ambiguous, automatically the language would be ambiguous. Then let me go with this. How can I say that it is ambiguous? We have two rules. See, first of all, it is a trial and error method. There is no particular algorithm existed to prove the ambiguity in a grammar. That's why we can say that the problem is undecidable problem. We cannot decide. We don't have any algorithm. It's a complete trial and error method. You have to take the strings and you have to prove it. There is no other way. Like how I did it. Sir, you might be knowing this string. That's why you got. Of course, I know it. That's why I took it. But how you have to take the another one? That you have to trial and error. You have to take the string and prove it. Take the string and prove it. If one string is not given, go with the other. For example, let me take it. S tends to ASR SAR and how to generate it. For the S tends to A, only one parse tree for the A string. Take one more string. S tends to AS, S tends to A. I got AA string. For this AA, can I generate one more parse tree? You'll check it. S tends to SA, S tends to A. I got the same AA with the two different parse trees. Now, yes. But with only one A, you cannot tell it. But with this AA, you can. So then how can you identify it? That's why I'm telling it's a trial and method. If there is such method to identify, I would have told you, right? Then that is decidable. It's not undecidable problem. Okay. So you have to just go with that. Then how to prove the, how to eliminate the ambiguity from the grammar. So first one is you can introduce a new non-terminals. Like say, for example, here you are having, okay, let me go with this. E tends to N, right? E tends to E plus E expression. E means expression only. E tends to E into E. To overcome this, we can introduce a new non-terminals, but not changing the language. So you can take this E tends to N and E tends to E plus T. You can take it. And E tends to E plus T. You can take this. And finally, the T is having what? N or non-term symbol. Then you can take T tends to N. So the same grammar you can write like this. by introducing a new non-terminal for the duplicate non-terminal here. So now this grammar generated by this will be same, but it won't give you the ambiguity in it. So how can we remove the ambiguous grammar? Just by introducing the new non-terminals, right? Or by can remove the left recursion or left associative, whatever it is, right? So that we will discuss in the next unit how to eliminate the left recursion. So this is one way. Then, for example, if I'm having like this, S tends to SA. So if the left hand side non-term is occurred as a leftmost symbol, that we can take it as left recursion. So by changing the grammar from left recursion to right recursion, sometimes we can eliminate the ambiguity. Sometimes, not every time. Right? So now here see we have just replaced the left recursion with the right recursion. So we'll discuss more about this recursion things in the next unit. That in the third unit we'll be having the left recursion, how to eliminate it, or I think in the next video maybe we'll discuss this. We have some types of it. Okay. So in the next video we'll discuss about push down automata.